So today we're just going to do a couple problems, all right? Jumping right into the examples, and it's just using implicit differentiation, okay? So if x squared minus xy plus y squared is equals 7, the first thing I want to do is find the tangent at -1, 2, okay? So that means the equation of the tangent line, all right? So the very first thing is we want to find dy over dx, okay? So we want to find dy over dx. Okay, so the way we're going to do that is we're going to take the derivative with respect to x of both sides of this equation. So that's d dx of x squared minus xy plus y squared, and then also take the derivative with respect to x of the right side, which is 7. Okay, now one thing we got to pay attention to, all right, and it's this right here is a product. So we have to use the product rule on this, okay? If it's a product of a constant, we can just do the constant rule, okay? But if it's the derivative of two things that we're multiplying together that aren't constants, we got to use the product rule, okay? So we got to use the power rule on this x squared. So that'd be 2x to the first power, which I'm not going to write, and then the derivative of the inside, which is x with respect to x. So that'd be times dx over dx. Now, to keep things simple, I'm going to write this as minus, and then I'm going to apply the product rule to x and y. So the derivative of x with respect to x would just be dx over dx, and then times the second piece, which is y, and then plus x, the first piece, times the derivative of y with respect to x, which would be dy over dx. And that's the product rule, okay? And then plus, and now we got to take the derivative of y squared with respect to x. So that would be 2y, okay? And then times the derivative of the inside, which would be dy over dx, and then equals, and then the derivative of 7 is just 0. Okay, so cleaning this up, this would just be 2x because dx over dx is 1. And then we have minus, okay, and then this would just be y, and then minus x dy over dx, and then plus 2y dy over dx is equal to 0, okay? And what I would do, I'm going to move these two over to the other side, and I'm going to write the 2y dy over dx first because it's positive, okay? So I'm going to rewrite this as 2y dy over dx, and then minus x dy over dx is equal to, and then because when I move this minus y, when I move it over, it becomes positive y, I'm going to write just y, and then minus 2x. Okay, so now I can factor out the dy over dx. Okay, and that'd be dy over dx times 2y minus x is equal to y minus 2x, and then I'm going to divide by that. So dy over dx is equal to y minus 2x over 2y minus x. Okay, so now we have the derivative rule to find the slope of at any point, and it's determined again by x and y. So what I need to do next is find the derivative at this point that was given, -1, 2. So dy over dx at, and then -1, 2 is equal to 2 minus 2 times -1 over, and then this would be 2 times 2 minus -1. So this would become 2 plus 2, which is 4, over, and then this would be 4 plus 1, which is 5. So my slope is 4/5 at this point, okay? I already have the point, all right? So I have the slope. The slope is 4/5. The point is -1, 2. I can write my equation of my tangent line, okay? And so then my tangent line would be y is equal to 4/5 times x plus 1, because I need to move it to the left 1, all right, and then plus 2. And that's my equation of my tangent line right there, okay? So now the next part, it has to do with normal line, okay, and we'll do that one next. So to find the normal line at the same point, okay, I need to know, okay, so my slope that's tangent is 4/5. Therefore, my slope that's perpendicular or normal, because remember normal means perpendicular, would be the opposite reciprocal of this. So opposite means different sign. So this is positive, ours is the normal slope would be negative, and we have to do the reciprocal, which is the flip of this. So that'd be 5/4. And we still need to go through this point. So our equation for our normal line would be y is equal to negative 5/4 times x plus 1 and then plus 2. Okay, and that's the equation of your normal line, okay? So maybe I should write normal line here. All right. All right, let's go to the next problem, and then that's it. We'll be done, okay, for today. Okay, so for this next problem, we have 2x cubed minus 3y squared equals 8, and I want to find the second derivative of y with respect to x for the second time, okay? So the very first thing I need to do is just find dy over dx first, okay? So I'm going to find dy over dx, okay? And so I'm going to take the derivative of both sides of this equation with respect to x. So 2x cubed minus 3y squared equals, and then the derivative with respect to x of 8. Okay, so this is going to be 2 times 3x squared, and I got to take the derivative with respect to x of x, so that'd be times dx over dx, and then minus, and then this would be 3 times 2y to the first, which I'm not going to write, okay, and then times the derivative of y with respect to x, which would be dy over dx, and then that's going to equal 0 because the derivative with respect to x of 8 is just 0. So cleaning this up, this would be 6x squared, all right, and then minus 6y times dy over dx, and that's equal to 0. Since the dy over dx is negative, I'm going to move that one over to the right-hand side, okay? You wouldn't have to, all right? Then that would be 6x squared is equal to 6y dy over dx, and then I'm going to divide both sides by 6y. So I'm going to write dy over dx on the left-hand side, but it would be 6x squared over 6y. And so I know from this that dy over dx, the simplified version would be x squared over y. All right, that's the first derivative, okay? All right, and what we have to do is to take the second derivative. We got to take the derivative with respect to x of both sides of this, okay? So now we're going to find the second derivative of y with respect to x for the second time. So that is d dx of dy over dx is equal to the derivative with respect to x of x squared over y. Okay, so you start to see how the notation works, right? You have d, the second derivative of y with respect to x for the second time. So that's why we have d, it looks like d squared y. It's not, okay? It's the second derivative over dx squared, like that, okay? Now, something we got to realize is this. This is a quotient right here, okay, of x squared and y. This is a quotient, which means we have to use the quotient rule, all right? So here we go with the with the derivative, the quotient rule. So we got to take the derivative of the top with respect to x. So that is going to be 2x times the derivative of this inside with respect to x, so times dx over dx times the bottom, so that'd be y, and then minus the top, x squared times the derivative of y with respect to x. So that would be dy over dx, all over the denominator, which is y squared. Okay, so that means the second derivative of y with respect to x for the second time turns out to be 2xy, and then minus x squared times dy over dx, all over y squared. Now, we want this in terms of y, okay? X's and y, I should say. So we don't want a dy over dx in our second derivative. So what we're going to do is we're going to take this and replace it. Now, what can I replace it with? Well, I already know from the first part that the first derivative, dy over dx, is x squared over y. So I can take this part right here, remove it, and replace it with x squared over y, okay? So that makes the second derivative of y with respect to x for the second time equivalent to 2xy minus x squared times x squared over y squared. We're going to do some more cleaning up because this is going to, right here, if you multiply this, this is going to become x to the fourth over y. So the second derivative of y with respect to x for the second time is 2xy minus x to the fourth over y, all over y squared. Now, we have a complex fraction, right? So what we have to do is we have to multiply and get rid of this denominator. That's the denominator that's hanging it up, right? That's messing it up for us. So we're going to multiply by y over y. And then when I distribute it, I'll have it. So the second derivative of y with respect to x for the second time is equal to 2xy squared minus x to the fourth over y squared times y. Well, that would be y cubed. Now, if you wanted to, you could do one more thing, okay, if you wanted to. So I'm not going to write another line because if you wrote your answer like this, I'm a happy teacher, okay? You could also factor an x out of this. It doesn't really help us, but you could, okay? And we would get 2y squared minus x cubed all over y cubed. All right, and that's how you go about finding the second derivative. So the idea is this: you first have to find the first derivative, and then you have to take the derivative with respect to x of both sides. And then if you, sometimes you will, sometimes you won't, you'll pick up dy over dx, okay? So if you pick up a dy over dx in the process of finding that second derivative, then you need to go back to the first derivative, replace it like we did right here, and then work it out, okay? And simplify it. Okay, that's it. That's it for today, guys. Short lesson today. Okay. All right. So have a great day. See you later.